All right, 11.6 is events involving nots and ors odds. So going back, remember the very first section that we did was and ors within diagrams? So the same thing is coming back here. So because P of E, which is the probability of event E happening, plus P not E, so the probability that it won't happen, adding those two probabilities together will give us 1, which makes sense because it's either going to happen or it's not going to happen. Those are only two options, so that'll give us 100% of our different options, which will be 1. So if I solve for P not E, the probability of E not occurring, that will be 1 minus the probability it does occur. So the probability that an event won't occur, will not occur, equals 1 minus the probability that it will occur. With that being said, the probability that it will occur is 1 minus the probability that it will not occur. So sometimes in a problem they give us, okay, this is the probability that it won't happen, find the probability that it will happen. So that's how whenever we use these formulas. So if it's impossible for events A and B to occur simultaneously at the same time, the events are said to be mutually exclusive. So simultaneously means at the same time. So if it's impossible for events to occur at the same time, so for example, it would be impossible for you to have a history class and a math class at 4:30 on Wednesday. You can't be in two places at once. So those two events would be mutually exclusive. So you either are in math at 4:30 or you're in history, for example, at 4:30. So we have this or option. So it's the probability of A plus the probability of B. If it's impossible for two events to occur at the same time, they're mutually exclusive. So in order to find the probability, we're going to take the probability of the first one and add the probability of the second. If it's possible for the events A and B to occur at the same time, then we have the probability of A or B is still the probability of A plus the probability of B minus the probability of A and B. So the probability of each one occurring by itself minus the probability of them happening together. Remember, going back to our Venn diagram stuff, whenever you have a Venn diagram, and if they happen at the same time, we had to kind of subtract some of it because they'd already occurred more than once. So it's the same concept here. We're subtracting the things because they're already accounted for with A and B. So, what else? Going back to our Venn diagrams. So if it's the probability of the event A happening, so this whole A circle, plus the probability of event B happening, so this whole circle. So if you notice, we counted this circle in the middle twice, because we accounted it for whenever we did the A circle, and we accounted for it whenever we did the B circle. We counted it twice. So we need to subtract that, so that way it only occurs once. If it occurred twice, we need to take one time out, so that way it only occurs once. That's what that's talking about. So odds in favor. So odds in favor of E can be found by taking the probability that E will occur and dividing the probability that E will not occur. Like usual, we'll do some examples of these in a minute. So the odds in favor of E can be found by taking the probability that E will occur and dividing by the probability that E will not occur. So if odds in favor of an event are A to B, A lot of times they rewrite this as A colon B. Then the probability of an event, the probability of that event would be A over A plus B. A plus B. So that's all of our definition parts. So now we're actually going to apply them with some examples. So first example, you're dealt one card from a 52 card deck. I've learned so much about cards in this class. So find the probability that you are not dealt a 6. Find the probability that you are not dealt a 6. So a big thing is not. So we're trying to find the probability of not getting a 6. So going to our first definition, we know the probability of not E equals 1 minus the probability that it will happen. So 1 minus the probability that you will get a 6. Because it's a lot easier to figure out, okay, how many 6s are in a deck of cards, and then do 1 minus that probability. So how many 6s are in a deck of cards? 4. So 1 minus, we have 4 6s out of how many cards total? 52. So remember, this is the number of 6s. And this is the total number of cards. So I have 1 minus 4 over 52. 1 minus 4 over 52. 4 over 52 is the probability of getting a 6. There are 4 6s out of 52 cards total. So going to our calculator can do all of this stuff for us. So we have 1 minus 4 over 52 is its own fraction, so I need to put it in its own set of parentheses. So 4 over 52. 1 minus 4 over 52 equals 0.92307, blah, blah. Pausing for a second. Did we all get that part? Okay, and then turning that into a fraction. So remember, above this PRB button says fraction of decimal. So second, fraction of decimal is taking our answer and changing it from a decimal to a fraction. Boom, 12 over 13, final answer. So our final answer is 12 over 13. Those of us who have a graphing calculator, same concept. Same concept. So we have 1 minus 4 divided by 52, still in parentheses. We get that same decimal. Now we're going to hit the math button. So this button right here. Into a fraction, press enter. Turning that decimal into a fraction, we still get 12 over 13. So either calculator. So either calculator, how could I help you? Questions for me? I seen it. Go for it. Yeah. I know you better than that. What fraction? But then you have to do 1 minus. Yeah. Oh, change that into 52 over 52? Or you want to simplify this fraction? Yeah, that's okay. So what would it be? 2 over... Okay, so 1 over 13. And then we know 1 is 13 over 13. So 13 minus 1, bingo, same thing. Yeah, go for it. Everyone from my experience, everyone freaks out and they get to this part, and then from the answer to this part, I don't know what happens. Math happens, that's the problem. So that's, you just don't let that part scare you. I'm not testing your fraction knowledge, so as long as you get 12 over 13, that's totally cool with me. Whether you do it by hand, which is what you should do, so thank you. Or if you plug it into the calculator, as long as you get 12 over 13, that's cool. Thank you. Other questions? Other questions? So let's do another one. The table shows the distribution by age of a random sample of 3,970 moviegoers. The ages range from 12 to 74. If one moviegoer is randomly selected from this population, find the probability expressed as a simplified fraction that the moviegoer is not in the 65 to 74 range. So, it's easier for us to see the 65 to 74 range. I can see that it's 800 out of our total, we're good to go. So instead of adding up all those other probabilities, we can do the probability, just like we did on the previous problem, that they are not 65 to 74. The probability that they're not 65 to 74, we know is 1 minus the probability that they are 65 to 74. So again, we have 1 minus. How many were 65 out of 74? Or 65 to 74? 800. So 800 out of how many total were sampled? Perfect, 3,970. This is our total. So again, in our calculator, we have 1 minus, in parentheses, 800 divided by 3,970. We get 0.7984, blah, blah, blah. Turning that into a fraction, we get 317 over 397. By the way, your calculator simplifies it for you. So if you did it in your calculator, that is the simplified version. So that's it. Final answer. Cold. I think it's cold back there and hot up here. Yeah, I'm always rushing. Oh, your milkshake? Yeah, problem. All right, how can I help you on this? How do you feel so far? This type of stuff. Decent? You ready for another one? So if you're dealt one card from this 52 card deck, find the probability that you're dealt a 3 or a black card. So we have to see, are these mutually exclusive? Can they happen at the same time? Could you be dealt a 3 and a black at the same time? Yeah, there are some cards, you can have one card that's 3 black. So what, clubs are black? No. Okay, so you can have a 3 of clubs and a 3 of spades, and you'll get a 3 and a black at the same time. So they are not mutually exclusive. They can happen at the same time. Not mutually exclusive, which means they can happen at the same time. So going back to the beginning stuff that we did, if we have the probability of A or B, it tells us 3 or black. We had probability of A plus probability of B minus the probability of both A and B. That was our formula from the very first notes part that we did, the definition part. So we're trying to find the probability that you would get a 3 card or a black card. Oh, come on. So probability of a 3 card or black card. We have the probability of getting a 3 plus the probability of getting a black card minus the probability of getting both. How many 3s are in a deck? 4 out of 52 total. How many black cards are in a deck? A lot, 26, good. They're either red or black, right? So half the deck is red, half the deck is black. So 26 out of 52 minus, here we go. Out of those 4 3 cards, out of the 4 cards that are 3s, how many are black? 2. 2 are black, 2 are red. So 2 out of the total 52 cards.
Now got the 2 how?
There's 4 3 cards, right? Half of them are red, half of them are black. So 2 are red, 2 are black.
So the 2 that are black are the ones you count?
Yeah, because we're looking for how many cards are 3 and black. So we're adding fractions. So we know whenever we add fractions, we have to have a common denominator. We do have a common denominator here. They're all 52. So we can just add and subtract our numerators. So 4 plus 26 minus 2 will give us 28. So those of you who really don't like fractions, plug this whole thing into your calculator. 4 divided by 52. It's its own fraction, so it goes in parentheses to separate it from the other fractions. Plus 26 out of 52, still in its own parentheses, minus 2 out of 52 equals, we get a crazy decimal, 0.538461538. Changing that decimal into a fraction, we get 7 over 13, which is our simplified fraction. That is our answer. The same thing for a graphing calculator. Questions, comments, or concerns for me? How could I help you so far? How can I help you so far? All right, if not, let's go on to the next page. Next page. Next example. The mathematics department of a college has 7 male professors, 6 female professors, 13 male teaching assistants, and 14 female teaching assistants. If a person is selected at random from the group, find the probability that the person selected is a teaching assistant or a female. So we're trying to find the probability of teaching assistant or female. So we need to see what formula to use. Are these mutually exclusive? Can they happen at the same time? Can one person be a teaching assistant and a female? Yeah. So these are not mutually exclusive. Which again means can happen at the same time. So we're going to use the same formula that we did on the previous problem. The probability of A or B is the probability of A plus the probability of B minus the probability of both A and B happening. So that's the formula that we're going to use. So we're trying to find the probability of a teaching assistant or female. So that means the probability of being a teaching assistant minus the probability of being a female. Sorry, plus minus the probability of being both a teaching assistant and female. So now all we have to do is plug in our numbers. Say it one more time. You'd add what? Used to? Yeah, that's just our formula. So how many are teaching assistants in general, whether they're male or female? How many are female, whether they're a professor or a teaching assistant, is females in general, and then minus the probability of both, because that was already accounted for over there. So it's like double jeopardy. I don't want to count them twice. Like double dipping. Because they were already accounted for in the previous. So let's do that. So teaching assistants. So how many teaching assistants are there total at this college? 27. Good. How'd you get that? Good. There's 13 male, 14 female. So total we have 27 teaching assistants. Out of how many people total? How many people are we talking about total? What is it? 40? 40. Perfect. Thank you. So 7 male professors plus 6 female plus 13 teaching assistants, 14 female teaching assistants. So total that will give us 40 people that we're talking about in general. So our first probability is the teaching assistants. So whether male or female, doesn't matter. So that's 27 teaching assistants out of our total 40 employees. Plus, how many people in this group of 40 are female? Just in general female. I don't care if they're professors or teaching assistants. 20. So 6 are female professors plus 14 are female teaching assistants. So plus 20 out of our total 40 math department people. Minus, because we already counted them in the first two fractions, how many are teaching assistants and females? 14. 14 are female teaching assistants. So we already counted those 14 over here, so I need to subtract so that way I only count them once. So same thing, plugging this into our calculator, 27 over 40 plus 20 over 40 minus 14 over 40. Putting that all into our calculator, we get 0.825. Changing that decimal to a fraction, we get 33 out of 40. Final answer. $33 out of 40. Three more. Pausing for a second. How could I help you? Questions for me? Questions for me? If not, let's do another one. The table shows the educational attainment of the population of Mars, ages 25 and over. Like, why would they pick something? Okay. Expressed in millions. Find the probability that a randomly selected Martian, age 25 and over, has not completed 4 years of college or more. 4 years of college or more. That's what we're looking for. They're all 25 and over. So how many have not completed 4 years or more? So we are looking for the probability that they have not completed 4+ years. Not completed 4+ years. It doesn't say anything about male or female. I can easily find the total who have completed 4+ years. So just like the previous couple problems that we did, let's do 1 minus the probability that they did complete. Four or more years. The 1 minus the probability that they did complete 4 or more years. So we'll have 1 minus. How many total completed 4 or more years? How many total completed 4 or more years? So we're looking at 4 or more years column. What is it? How do you get that?
Do we add them all together?
Okay, so this one is just for female. This one's just for male. And then total, we have this last row is our total. So total is 43. So 43. Out of how many people are we talking about in general? 172. So 43 completed 4 or more years. And then 172 is the total number of people. So in our 4 or more year column, the bottom row is our total. So we have 43 total. Our complete total of the whole chart is 172. So in our calculators, 1 minus 43 over 172. 1 minus 43 over 172. We get 0.75. Changing that decimal into a fraction, we get 3/4 as our final answer. We get 3/4 as our final answer. What questions do you have for me? Whether it's on the problem, whether it's on the calculator, what questions do you have? How could I help you? All right, let's do another one. Last two. A single die is rolled. Find the odds in favor of rolling a number greater than 2. The odds in favor. My other class, I'm so worried about factoring. The odds in favor of rolling a number greater than 2 are blank to blank. So going back to those definition stuff that we did, we said the odds in favor of an event occurring is the probability that the event will occur divided by the probability that the event will not occur. The odds in favor of something happening is the probability that it will happen divided by the probability that it won't happen. So we're looking for the probability of a number greater than 2. A number greater than 2 divided by the probability that number is not greater than 2. And this means not greater than. So what's the probability of number greater than 2 divided by the probability that it's not greater than 2? So on our die, remember dies are 6-sided. So like a cube has 6 sides. So 1 through 6. Out of the numbers 1 through 6, how many numbers are greater than 2? 4. So we have 3, 4, 5, 6. So 4. How many out of how many sides total? 6. So 4 bigger than 2 out of 6 total. Out of our die, out of our 6-sided die, how many numbers are not bigger than 2? 2, 1 and 2. So we have 2 out of our 6 total. So we're dividing fractions. So that means this fraction bar means we're dividing fractions. So I can rewrite it as 4 over 6 divided by 2 over 6. 4 over 6 divided by 2 over 6. How do we divide fractions? You want me to be hungry? KFC. Stay, change, flip, keep it, flip it, change it, whatever. I'm going with stay, change, flip, whatever you want to call it. Multiplying by the reciprocal. So our first fraction is going to stay the same. Our operation is going to change from division to multiplication. And we are going to flip our second fraction. The first fraction stays the same. Our operation changes from division to multiplication, and we're going to flip our second fraction. Now what? Okay, the 6's can cancel. What's left over up top? 4. What's left over on the bottom? 2. Simplifying this. 2 over 1. Good, they both have a 2 in common. So we have 2 over 1. That is our final answer. They want it written as a ratio, because 2 over 1 is a ratio, 2 to 1, which we could say 2 to 1. So they can write it in any one of these 3 ways. 2 over 1, 2 to 1, or 2 colon 1. This is straight from the problem in my math lab, and they had it written like this. That's why I wanted to include it in the notes. So I've seen your faces. I know a lot of us don't like this stuff. I know. Yes, you can plug it into your calculator. I just like to show you why. That gives me a little anxiety. So we could still do in our calculator 4 over 6 in parentheses because it's its own fraction divided by in parentheses 2 over 6. Boom, we get 2. I have to write it as 2 to something, so it's the same thing as saying 2 over 1. So yes, your calculator can do it for you. All right, before we do this last one for 11.6, how could I help you? Questions for me? All right, so if not, last one. Last one. This time you're given the odds of 6 to 7 in favor of winning a bet. So now what's your probability? What's your probability of winning that bet? So going to whatever we did in the beginning. So if they give us, the odds of A to B in favor of winning, our probability that it will occur, that we will win, equals A over A plus B. Probability 6 to 7, so that's probability of A to B in favor of winning. And the probability that it will occur is A over A plus B. So if our odds in favor are 6 to 7, what is our A value? What's our A value? So this time we have 6 to 7. So A is 6, B is 7. So our probability of winning will be 6 over 6 plus 7. 6 over 6 plus 7. What is 6 plus 7? 13, so we have 6 over 13. Can this be simplified? Nope, final answer. What questions do you have for me? This is all of 11.6 notes.